So we started with this one and we found out a solution. Unfortunately, ended up just kind of being a grinded out method. But that works. Trying to find the right equation was what we struggled with at the time. This is where we just finished up. And we looked at this and I saw these equations going on, which was good. And I know I asked, make sure you define what your variables are somehow, so that as you're thinking about it, you can go back and say, well, what was what? The X was what the amount was in the 4% account. The Y was what the amount was that was in the 5.5% account. And then my Z account was my 6%. Those were the common variables I saw as y'all were working, which meant if I take all of those together, 4% of the X, 5.5% of the Y, 6% of the Z, that's $1,300. But then we also know X plus Y plus Z, the amount of each of the three accounts together, should be $24,500. So I have two equations with three variables, which typically means you can't solve that. If you have two equations, you can solve for two variables, three equations, three variables. But over here we have this one other notice. The 4% account was 4 times the amount in the 5.5% account. So X, the 4% account, is or was, when you're thinking about translations, was is past tense of is, and is equals, which means was is also equals. 4, so the X equals 4Y. Now, I can take that and plug it into the equations. So in the replacement of this X, 4% of X, 5.5% of Y, 6% of Z, replace the X with the 4Y, just substitution. Then this multiplied plus that simplifies to 215Y, 0.215. And I saw that on some boards as you were working through it. Is this. And then this equation, which was the X plus Y plus Z, I replaced the X with the 4Y in the other equation, 4Y plus Y, that's why I just have 5Y. One process would be then, I see these two equations, this equation here. If I solve this equation for Z, subtract 5Y, now I have Z. And then in order to solve, I need to put this into the other equation. I saw some people trying to solve for one and then putting it back into itself. And then you usually end up with 0 as your solution. Because it's like, well, but you plugged it back into itself, so what makes that true? And the answer is, well, it isn't true because it's the same exact equation. So you'd actually be finding out that it is the exact same, either an infinite number of solutions or no solution. All right, so when you're doing it, you have to remember I have to take this and put it into the other equation, which is why I keep, I'll work through things with different colors. I'll have pen and pencil. I'll do something to try to keep it separated out so that I can remember, because otherwise it's easy to lose track of what's happening. 0.215Y plus 0.06 times that whole thing, 24,500, minus 5Y equals 1,300. Then I will have only one equation and I have only one variable. You'll do distributive property. You'll combine like terms. You'll slide this value here. You'll subtract that over here. And you're going to go, well, that's a negative number. And that's okay because when I subtract this from that, it'll also be negative, and you'll divide, and when you're done, you'll end up with some value for Y. And the mistake would be to say I'm done, which you're not. Once you find that Y value, you can put it in here. And that'll tell you the Z value. And then I remember that, oh yes, the other thing I know is that X equals 4Y. So this Y would go into here to tell me the X. And if you do it right and you don't round, you'll get three numbers, X, Y, and Z, that all add up to 24,500. If you're off by a cent, that is okay in that process. So that's how you would have solved that. I'm not going to give you the final answer. I leave that to you to do that in whatever notes that you take and do. All right, 4.1 to 4.3, lots more of solving equations. Intersecting lines, if you draw two lines that intersect, two straight lines, how many ways can they intersect? Two straight lines.
Are they parallel?
That are not parallel can intersect either once or infinite. Because two straight lines that intersect. Right. So I'm not going to draw my axes here like this. There's two straight lines that intersect, and they will intersect at one point. Or I have this line, and then I have this line, which is the exact same line, one on top of the other. So this would be 1 point. This would be an infinite number of points because they intersect at every point. So if two lines intersect, if they intersect, they either intersect at 1 point or an infinite number. So in this process, we'd say, all right, where this section typically starts is saying, well, is this a solution? Fancy way for saying, does this point, is this the intersection of this line and that line? If the answer is yes, then when I put these numbers into here, it, quote, works. So the process would be, plug those in. Negative x, so it's going to be negative negative 1 plus 1. Negative negative 1 plus 1. Negative negative is a positive, so I have 1 plus 1, which is 2, which is 2. So that one checks. 2 times negative 1 minus 1. So if I go 2 times negative 1, that's negative 2. Minus 1 is negative 3, which is negative 3 and checks. The explaining part is important. When asked to explain, it doesn't mean just show your work. It means actually using words to explain what just happened. Yeah, so an explanation would be saying something along the lines of, the point negative 1, 1, when plugged into the first line for the variables, is a value that's on that line. Because when I plug it in, I got that 2 equals 2. When I use this point with the second line, I also find that this point is on the second line as well, which means if it's on that line, it's also what we would call a solution. So a solution to the system means since both lines have the same point, they share a point, that means those two lines intersect at that point. So to be a solution to a system means that whatever values I have, they work or they are validated within each equation. That was a lot of words. You could have said it with fewer words, but if you know me by now, you know that I typically have lots and lots of words. So then for each one here, I'm going to pause this video and I want you to try to crank through these quick as you can, showing your work as you can, and then we'll go through solutions quickly. So go. So when going through those, like I said, quickly, substitute in y is equal to 5. So I replace the 1y with 5. That's what it equals. That's what happens over here, and I get x equals 1. But what I didn't do is I didn't actually finish the problem. Because solving a system, solving each system requires me to have a point showing where the two lines intersect. Let me go back and make that blue. So my solution to number 1 is 1, 5. The y value was given originally as 5. I just found x. X is 1. The other one's 5. So those two lines, when graphed, the line y equals 5, which is a horizontal line, intersects with the line 2x plus y equals 7 at the point 1, 5. 2 I did not finish. I found the x value, but I did not write the solution. Solution should be 1, 5. And again, had to take this 1, put it in there for x. 5 times 1 is 5, so y is 5. In number 3, 2, 3, because this x goes back into this equation. It's the red stuff that I'm working with there. 5 times 2 is 10, and then 10 minus 7 is 3. And then I stopped on number 4 because when I do this one, I find out that 0 equals 4. And that's a problem. How often does 0 equal 4? Never. Since this never happens, that means they do not intersect. When you get something where you have two numbers that don't equal each other, somehow in my equation, I'm like, wait, 0 doesn't equal 4. What did I do wrong? Well, I know that mathematically I did everything right here. Plug that in for x, so I had 2y minus 2y. And 0, since 0 does not equal 4, they do not intersect. These two lines are parallel. If you were to do a problem like this and end up with 4 equals 4, how often does 4 equal 4? All the time. And that means those would be the same line, and there would be an infinite number of solutions.
So all right. That in the case, would we just say...
So elimination method. So what we just did previously is a substitution method. Sometimes the elimination method is better, where if I line these up, and somehow these aren't lined up super well, but I'm looking at my x's, looking at my y's, and if I were just to add the two equations up, could I eliminate them, one of my variables? And the answer is yes. I like to always do mine as adding. So if I go x plus negative x, I get 0 x's. I have negative 5y and positive y add up to negative 4y. That's a y. And negative 12 and 4 is negative 8. Divided by negative 4. And typically we don't write the 0, so I'll just get rid of the 0. Y equals 2. Then I got to pick one of the equations and plug that back in.
Wouldn't it be negative y is equal to 2?
It would be y equals 2 because I'm going to divide both sides by negative 4. Negative divided by negative is positive. Negative divided by negative is positive. I prefer the top equation only because the x is positive. And I know that when I work, where I make my mistakes is typically in missing negative signs. So the fewer I can deal with, the better. Take this and plug it in. X minus 5 times 2 equals negative 12. X minus 10 equals 12. Negative 12. Add 10. X equals negative 2. Final answer would be negative 2, 2. And that's the point where the two lines intersect. So that's the elimination method. If I have different coefficients, then it's choosing, and I can multiply one equation or both equations by something. In this case, these are both positive, these are both negative, which means I'm going to have to multiply one of them by a positive number and one of them by a negative. When I work on this, there's no reason, like I could do x's, I could do y's. It doesn't really matter. I'm going to multiply the top equation by -4 and the bottom equation by 3. When doing that, -12x, positive 8y, keep track of that negative, because I'm distributing that into each of them, equals -40. Bottom equation, now I'll have 12x minus 9y equals 45. Add. And I chose those values so that these would add to 0. 8y and negative 9y when added together will be -y equals positive 5, y equals -5. Procedurally, take this number, put it back into one of these two equations, whichever you choose, to find the x value. And then when you do, you will list your answer as something, comma, -5. We've done that a few times. I'm not going to show that again. Elimination method. Here again on this one, it's nice because I can just add them straight up because the y's will add to 0. I will have 8x equals 16, x equals 2. Take that number, put it back up into one of the equations to find the y value, and it will be 2 comma something for a solution. Which method would you choose to use on this one? Multiply that top equation by 2. I'll bring that down here. I'll have -10x minus 6y equals 18. And now I'm going to add them up, but I did -2 so that when I did these two together, they add to 0. And then I have 6y minus 6y, which is 0 equals 0. When does 0 equal 0? All the time, so they are the same line, which means there are an infinite number of solutions. If you see me abbreviate SLN, that means solution. Now, if we try to get a little spicy, in a 3D coordinate system, all right, you've done X and Y. Z comes out at you like this, where it's X, Y, and Z. The process becomes more challenging because you have to really keep track of which equation goes to which equation. So if you're going to use substitution method, which you could, take this bottom equation and make it y equals 4z minus 3. I just added 4z to both sides. I could then take this and put it in up here for the y, so I'd have x and z. The second equation has only x and z, so after I substitute that in, I could use that in combination of the other one to continue working. It's just a matter of keeping track of which ones you're substituting in so that you make sure that you don't accidentally take this equation and substitute it back into itself. Then we really start to make a mess of things. So in plugging that in, and then I'll take this equation below it. So I plugged that into the top equation, did the work over here. If I bring this one down below, 4x minus 4z equals -1, I can see those and say, I can do some elimination method. If I multiply the second equation by 4, that top equation comes down. 2x plus 16z equals 13. Second equation comes down after multiplying by 4 as 16x minus 16z equals -4. Add them, 18x equals 9, x equals 1/2. And then you start thinking, oh, fractions. Yes, fractions. But if x is 1/2, then I got to find an equation up here that only has an x in it. There we go. I can plug a 1/2 in there to find y. I can plug a 1/2 in there and then solve for z to get the 3 points that make the coordinate of where x, y, and z.
So did we just find the lost one?
Similar to what we did before, you start looking at these and people go, oh no, word problems. Life exists as a word problem. It's a matter of taking it, see if I can translate it into math, and then solve it from there. $9,000 worth of new equipment to offer new personalized business shirts to its employees. The cost of producing one shirt is $3. So cost is $3 per shirt. It's being sold to the employee for $5.50. So they're selling it for $5.50
So they're making a $2.50 profit.
per shirt. So they're making $2.50 profit per shirt. How many shirts they need to sell to break even? Purchase it for $9,000. $1,686 shirts.
36.
36 shirts. I hear someone say 3,600 shirts. I get confirmation of 3,600 because if it's profit of $2.50 per shirt, 2.5 times the number of shirts needs to equal $9,000. You divided 9,000 by 2.5?
That's where I got to eventually, but I did
Yes.
9,000 times 2.
The measure of the smallest angle of a triangle. Ooh, triangles. Gotta love triangles. Don't assume that my picture is drawn to the proper scale. The largest angle. I didn't make that very easy to tell which one's the largest angle. Let's go like this. How about we go like that? Now you can tell the largest angle. The largest angle of the triangle, which is this one, is 80 degrees more than the smallest angle. So which one looks to be the smallest angle?
Far right.
The far right. So if I say this far right angle is x, because I don't know how much it is, and the larger angle is x plus 80, how do I know that? Well, it says it's 80 degrees more than. So that if that one's smallest, then that one's 80 degrees more than. And then find the measure of the remaining angle is 10 degrees more than the measure of the smallest angle. X plus 10. Wow, I've only got one variable. What do I remember about a triangle?
108 degrees.
It's a 30 degree, x is 30.
X plus 80 plus x plus 10 is 180. The sum of the three angles, interior angles of a triangle, adds to 180. 3x plus 90 equals 180. 3x equals 90. X equals 30. This angle equals 110 degrees. This one is 30 degrees. That one is 40 degrees. And hopefully if I did it right, all of it works. 110, 40, 30 adds to 180. The check your understanding problems for chapter 4 are here, which are listed on your modules as well. So I don't need to keep that posted.